Hello everyone, welcome to Inspire Mathematics classes. Now I am going to teach you on ordinary differential equation of first order and first degree in the form of di upon dx function of x and y, and which can be expressed in the form of m of xy upon n of xy, and this is implies that m of xy dx plus n of xy dy equal to 0. This is the first order and first degree differential equation having in this form. This differential equation will be exact if here m and here n, here m and here y. So partial derivative of m with respect to y, m here m and the right side y. So students, remember, with respect to y, del of partial derivative of n with respect to x, left side x. Okay, so this is, these two partial derivatives are equal, then this is exact differential equation. Okay, now then solution is integral m of xy dx plus terms of n of xy not containing x dy equal to c, where c is an arbitrary constant. Okay, so this is the m dx plus terms of n not containing x dy equal to c. C is arbitrary constant. This is the solution of this ordinary differential equation. Okay, so this differential equation will be exact if del m by del y equal del n by del x. M will be partial differentiate with respect to y, and this n will be partially differentiate with respect to left side, that is x. Okay, now if del m by del y not equal to del n by del x, then given O.D.E, ordinary differential equation, is not exact. Okay, at this time we multiply the equation by a suitable factor, becomes an exact differential equation. Okay, and this factor is called IF, that is integrating factor. Okay, this factor is called integrating factor. Now we going for finding IF integrating factors for non-exact differential equation having 5 rules. Okay, rule number 1. Rule number one is, if m of xy and n of xy are homogeneous of x and y of same degree, then integrating factor is 1 upon mx plus ny. This is the integrating factor. Okay, next rule number 2. Rule number 2 is, if given O.D.E in form of phi xy y dx plus psi of xy y x dy equals to 0. This is the form, means function of xy, that is function of x multiply y dx plus function of xy multiplied by x dy is 0. Then integrating factor is 1 upon mx minus ny. Okay, next we go for rule number 3, and rule number 3 is, if del m upon del y minus del n upon del x upon n is a function of only x, just in a function of only x, then integrating factor is e to the power integral fx dx. Okay, this is the integrating factor. Let's move to rule number 4, and rule number 4 is, when del m upon del y minus del n upon del x, that is rule number 3. Students, carefully observe, for rule number 3 in the numerator and rule number 4 in numerator are the same. Okay, just in denominator is different. In numerator as it is, but denominator here is m. And if this is the function of only y, this is the only function of y, then integrating factor is e power minus integral gy dy. This is the integrating factor. Okay, next move to rule number 5, and rule number 5 is, if O.D.E ordinary differential equation in the form of in the form of x power a y power b common my dx plus nx dy. Here y dx, then here x dy. You can remember in this way. Plus here x power x, y power b, here a b c d. Y dx, here is also y dx plus x dy. Mn, here p and here q equals to 0. If this ordinary differential equation in the form of, then where a, b, c, d and mn and pq all are constants, okay, constants, then integrating factor is x power s multiply y power k, where h and k constants determined by the equations a plus h plus 1 upon m equals to b plus k plus 1 upon n and c plus h plus 1 upon p and d plus k plus 1 upon q. Okay, now let's move to question number 1. These questions are very important for semester exams of BTech students. Okay, question number 1 is and the question number 1 is solve e power x sin y dx plus e power x plus 1 cos y dy equal to 0. This is the ordinary differential equation. Now we are going to solve this question, and the solution is here. Obviously here m is a function of x, m dx, so this is m e power x sin y, and n m dx plus n dy, so this is n, okay, this is n, so n is e power x plus 1 common cos y, this is n. Now we have to check this differential equation either exact or not. For checking the exact differential equation, first of all we determine the partial derivative of m with respect to y, that is del m upon del y is e power x sin y. Del m upon del y means partial derivative of m with respect to y, treating x as a constant, and here e power x sin y, so derivative of so here e power x sin y, so derivative of m with respect to y is sin y, this is cos y, okay, cos y, and e power x as it is, because x is constant, so e power x is constant, e power x as it is, and derivative of sin y is cos y, and del n upon del x is partial derivative of n with respect to x, y as a constant, here cos y constant, so cos y, and derivative of e power x is e power x, and plus derivative of cos y is 0, so this is e power x cos y. Now here we see del m upon del n upon del y is del n is del x. Okay, this is the del m upon del y, and this is del n by del x is e power x cos y. These two partial derivatives are same. Del m upon del y means partial derivative of m with respect to y, x as constant. So e power x is constant as it is, and derivative of sin y is cos y, and here n with partial derivative with respect to x, so x is variable and y is constant, so cos y is constant as it is, and derivative of e power x is e power x, and plus only constant cos y, so its derivative is 0. Now this is e power x cos y. So since del m upon del y equal to del n by del x, so the differential equation is exact given O.D.E is an exact. Okay, therefore general solution GS, therefore general solution is integral m dx plus terms of n not containing x dy equal to c. C is an arbitrary constant, and next step is integral m is e power x sin y dx plus terms of n not containing x. In the n we have seen e power x cos y plus cos y, so cos y is the only term not containing x, so here cos y, okay, dy equals to c, arbitrary constant, and now this integration is with respect to x, so y as constant, so sin y as constant, so sin y as it is integral e power x dx. Here cos y integration is cy equals to c, and this is e power x sin y plus sin y equal to c. Okay, where c is an arbitrary constant. This is my final answer. Okay, next move to question number 2. And question number 2 is solve x power 4 y power 4 dx minus x y cube dy equals to 0. Now solution is here clearly m dx plus n dy. So m is function of xy is x power 4 y power 4, okay, and here n is minus x y cube. This is the m function of xy, this is n function of xy. For now we have to check this differential equation either exact or not. This is the first checking before solving, either exact or not, and for checking exact we find partial derivative of m with respect to y, treating x as a constant. So here x is a constant, that is x power 4 derivative is 0, and derivative of y power 4 with respect to y is 4y cube, that is 4y cube. Okay, and now del n by del x is the partial derivative of n with respect to x. Therefore x as variable, y as constant, and y is constant means y cube minus y cube as it is, and derivative of x with respect to x is 1, so minus y cube. So obviously we have seen here, since del m upon del y not equal to del n upon del x. So obviously, since here del m by del y not equal to del n by del x, so differential equation is not exact. Okay, so differential equation is not exact. Differential equation is not exact. So students, observe that m and n, the given equation is x power 4 y power 4 dx minus xy cube dy equal to 0. Carefully students observe x plus 4y power 4 and here xy cube. So power of x is 4 and power of y is 4, and here power of x and y, not either x or y, x and y power is 1 plus 3 is 4. So total all powers is 4. So is the matching for rule number 1. This m and n, this is m and this is n. Both are the functions, homogeneous functions of same degree x and y. So using rule number 1, integrating factor is 1 upon mx plus ny. 1 upon mx plus ny is 1 upon, here m is x power 4 y power 4 x plus n, and n is minus y cube multiplied y, and 1 upon x power 5 y power 4x minus x y power 4, and this is 1 upon x power 5. This is the integrating factor. Now multiplying this integrating factor of the given differential equation. Okay, now multiplying the differential equation by if, and we get x power 4 y plus 4 upon x power 4 dx minus xy cube upon x power 5 dy equals to 0, and this is after simplification 1 upon x plus y power 4 x power 5 dx minus y cube upon x power 4 dy equals to 0. Now this is an exact differential equation. Okay, after multiplying this integrating factor, after multiplying the given equation, this integrating factor, now this becomes this equation, which is an exact differential equation. Therefore general solution is GS is integral 1 upon x plus 1 y 4 by x power 5 dx plus terms of n not containing x, but here in the n terms of n not containing x is 0. Okay, so and see, this is constant, this is log x plus the integration with respect to x, so y is constant, and this is minus 1 upon 4x power 4, and this is constant, so this is constant, so total is a constant. Okay, and this is log x 4x power 4 minus y power 4 is 4c x power 4. This is the required, this is my required answer. C is an arbitrary constant. Okay, let's move to question number 3. Let's see the question number 3. Solve 3x square y power 4 plus 2xy dx plus 2x cube y cube minus x square dy equals to 0. Now we going to solution of this equation. This is very important for these students. Okay, so these questions are very important for the semester exam of the BTech students. So keep watch, and if you like this video, to share it with your friends and juniors and seniors, and don't forget subscribe to my channel to get more updates and more. This is important types video. Okay, now solution is, here m is 3x square y power 4 2xy, and n is 2x cube y cube minus x square. Let's this equation carefully. If you observe, here total power of x and y is 6, but here 2, here 6, here 2. So this is not, we cannot use rule 1. Rule 1 is cross, okay, but rule 2 is also cross, because rule 2 is a function of xy and x dy, y dx, and is the function of xy. So this is not a function of xy, this is the function of xy, but here function of not xy, because function of x power 2 and y power 4. Okay, so this is the not a function of xy. So this is the not belongs to rule number 2. So this differential equation for finding integrating factor, rule 1 and rule 2 is cross, and rule 3 or rule, either rule 3 or rule 4 maybe. Okay, so let's we have see here del m upon del y. First of all, find del m upon 12x cube x square y cube. Okay, and del n upon del x is 6 square y cube minus 2x. Okay, so del m upon del y minus del n by del x by m, we have 6x square y cube plus 4x upon 3x square y power 4 plus 2xy, and this is 2 upon y after simplification, which is a function of y. This is a only function of y. Okay, this is only function of y. So integrating factor is, so since this is only function of y, so this is rule number 4. Okay, so using rule number 4, we have integrating factor is e power minus integral g of y d of y equals to e power minus integral 2 upon y dy, and this is e power minus 2 log y, that is 1 upon y square. This is the integrating factor. Now we multiplying this integrating factor 1 by y square of the given differential equation, and we have 3x square y power 4 by y square dx plus 2 1 upon y square 2x cube y cube minus x square dy equals to 0, and this after simplification we have 3x square y square plus 2x y dx plus twice x cube y minus x square upon y square is dy equals to 0. Okay, which is an exact differential equation. So therefore general solution is integral m dx. Here m is 3x square y square plus 2x upon y dx plus terms of n not containing x. This is the n, okay, and this is the m. So integral m dx plus terms of n not containing x. Carefully observe here in the n, terms of n not containing x, terms number 1 and terms number 2 in n, but here is also x, here is also x, so terms of n not containing x is 0. Okay, this is integrating constant, arbitrary constant, and this is, after simplification, this is x y cube y square plus x square upon y equal to c. C is an arbitrary constant, and this is my final answer. This is the required solution of the given differential equation. Okay, now try yourself. Question number 1, solve twice sine y square dx plus xy cos y square dy equals to 0. So students, if you are able to solve this question, comment your answer. Thank you so much for watching this video till the end, and we have various kind of videos regarding differential equation, integration, differentiation and other chapters. So keep watch and don't forget subscribe and click bell icon for updates. Okay, have a good day.